Megan Breitbach, and this is my extra credit video. So we watched a video of the world's largest rope swing, and we guessed that they were using Kernmantle rope, and that it was 150 feet long. We also guessed that it was an 80-kilogram person swinging on the rope. So to find the final velocity at the bottom of the rope swing, we set the potential energy equal to the kinetic energy, and we ignored mass and found that the velocity final was 29.94 meters per second at the bottom. We then calculated the tension of the rope at the bottom of the swing, and to find that, we took the negative force of gravity minus the centripetal force plus the tension, and so we found T, or the tension, to be 2,352.5 newtons, or about 3 Gs. So for 30 degrees from the bottom, we used a displacement of 150 feet times cosine 30, which is equal to 39.59 meters. Then we found the final velocity to be 27.86 meters per second, and the tension of the rope we multiplied the tension by sine of 60 degrees and subtracted the force of gravity and the centripetal force times cosine 30, and found that the tension was about 2,263.4 newtons, or 2.89 Gs. To find the spring constant of the rope, we looked up on the internet to find the Ks of Kernmantle rope is 176,000 newtons per meter. Our rope is about 45. So by dividing the Ks of the Kernmantle rope by the length of our rope, we found the Ks to be 3,849.52 newtons per meter. We then found that the force of the tension of the rope is equal to the force of the spring. So the tension force was 2,352.5, and we set that equal to Ks, and found that the stretch of the rope at the bottom of the swing was 0.611 meters, and at 30 degrees from the bottom it was 0.588 meters. So we did all this on a Python code, which is right here, and we'll run it one time through to show the total swing with a time less than 20 seconds. And we have the perpendicular and parallel components, force components, shown with the arrows. Alright. And then we'll run it through to find the bottom of the swing at a time less than 4 seconds. And you'll see that that's approximately the bottom of the rope swing. And then we'll find where the rope swing, or we'll show the rope swing going through 30 degrees from the bottom. Using T is less than 3.5 seconds. Alright, and next we're going to show the calculations from the code. So the final position of the hanging mass for the bottom of the rope swing is about negative 46 meters, which is about what we got when we did our calculations on paper, and the final velocity to be about 29.8276 meters per second squared, which is also about the same as what we got. Then for 30 degrees from the bottom, we found the position to be 43.69 meters, and then the final velocity to be 27.25 meters per second squared, which is as well the same as what we got.